Still got about 11, I think 11 or 15 people missing.
There are many checks before you get to activating the blowout preventer. That is the ultimate fail-safe mechanism.
The dark secrets of fossil fuels, how oil and coal shaped our past and threaten our future. Mining, drilling, and the use of filthy energy have long harmed the environment. Many environmental repercussions are associated with the production of a large portion of the world's energy from materials produced hundreds of millions of years ago. Demands on the oil and gas sector to explain the effects of energy transitions on their operations and business models are growing. But are oil and coal threatening our future? Find out by watching this video. The majority of energy required to run our automobiles, run our businesses, and keep the lights on in our houses has been produced for more than a century by burning fossil fuels. Today, over 80% of our energy demands are met by oil, coal, and gas. And now we must pay the price. Fossil fuel use has devastated mankind and the environment that goes beyond the detrimental effects of chemicals and polymers made from petroleum. Discover what fossil fuels are, how much they cost us, which goes beyond our wallets, and why it's imperative to transition to a future powered by sustainable energy. Coal, oil, and methane gas make up a whopping 15% of the approximately 100 billion tons of materials generated annually worldwide. A massive amount of infrastructure is associated with extracting, processing, transporting, and burning 15 billion tons of fossil fuels, around half of which is coal. All fossil fuels, when burnt, produce waste. Methane gas and oil produce little solid waste, but all, including coal, have greenhouse gases, pollutants that are rapidly heating the planet. Here's an interesting fact. Burning a ton of coal actually produces over 2 tons of carbon dioxide emissions. That's because the carbon atoms in the coal react with oxygen in the air to make carbon dioxide. Over 70% of the weight of a carbon dioxide molecule is the 2 oxygen atoms. What is left over from burning a ton of coal? There's about 150 kilograms of coal ash and 6 kilograms of assorted gases and solids, including sulfur dioxide, nitrogen oxide, uranium, thorium, mercury, and other compounds. That's over 1.1 billion tons of solid waste annually, typically accumulating in vast slurry ponds and spent water. Leaks into local waterways are common, and that's just at the burning stage. How about at the mining stage, where landscapes are converted into dystopian moonscapes? Did you know coal mining is one of the most freshwater-intensive industrial activities? Coal needs to be washed to remove impurities, producing vast amounts of polluted water, much of which returns to local waterways and aquifers. Extracting the coal also upsets the local water table and buries streams. In fact, it has been estimated that producing and burning each ton of coal requires about 230 to 310 tons of fresh water. Mining coal often releases significant quantities of methane trapped in coal seams. This potent greenhouse gas is over 80 times more powerful at trapping heat in the atmosphere than an equivalent mass of carbon dioxide. Meanwhile, in addition to their greenhouse gas contribution, which also includes methane releases from wellheads, gas pipes, industrial plants, and domestic appliances, the consumption of gas and oil is the largest industrial source of emissions of volatile organic compounds that contribute to the formation of ground-level ozone. The exposure to the ozone is also linked to a wide range of health effects, including aggravated asthma, increased ER visits and hospital admissions, as well as premature death. Human exposure to fossil fuel air pollution is estimated to account for the deaths of at least 8 million people globally annually, nearly 1 in 5 deaths from all causes. The oil and gas sector is being put under further pressure to explain the effects of energy transitions on their operations and business models, as well as how they might help reduce greenhouse gas emissions and achieve the Paris goals. Numerous oil and gas firms are facing increasing social and environmental challenges, which raises complicated considerations regarding the place of these fuels in a shifting energy economy and their place in the societies in which they operate. But the fundamental concern in the context of increasing GHG emissions is very straightforward. Should current oil and gas corporations be seen as solely contributing to the issue, or may they also be essential in finding a solution? The vast variety of oil and gas corporations and company strategy around the world makes it impossible for this research to offer concrete solutions. It does attempt to outline the risks that various segments of the industry face and the variety of options and solutions. The strategic issue for the oil and gas sector is to strike a balance between short-term profits and its long-term operating permit. Both energy services and carbon reductions are in demand from society. The question that oil and gas firms must now answer is whether they can contribute to the delivery of climate solutions. Oil and gas corporations have been adept at supplying the fuels that constitute the foundation of today's energy system. The expenses associated with creating low-carbon technologies are an investment in the long-term success of businesses. This could be accomplished, according to the analysis of this paper, if the oil and gas sectors take the required action. As a result, it creates a pathway for oil and gas industry to interact with the Grand Coalition, which the IEA views as crucial to combating climate change and which some businesses are already taking. This effort would be considered boosted if additional oil and gas corporations were firmly and totally on board. Renewables have a negligible material footprint. A solar panel weighs about 20 kilograms. A typical 2 to 3 megawatt wind turbine around 200 tons, including its concrete footing. Equating this to 15 billion tons of fossil fuels, you could install around 75 million wind turbines for the same material mass. Globally, primary energy consumption for all uses electricity, industry, and transport. A standard solar panel produces about 300 watts around 20% of the time over the year, but it doesn't produce at night and produces less during winter and cloudy conditions. That's about 525 kilowatt hours per panel per year. Therefore, it would take over 221 billion solar panels to generate all the energy the world currently uses in a year, weighing about 4.4 billion tons. Typically, solar panels work with minimal maintenance for at least 25 years. Offshore wind, which is more consistent, has produced capacity factors as high as 57% over 12 months of operation. Meanwhile, a well-located onshore wind farm can achieve capacity factors exceeding 30% and a service life of 20 to 25 years or longer. The typical turbine size installed in the US in 2020 was 2.25 megawatt hours. Taking a conservative 30% equates to 7.2 gigawatt hours of energy per turbine per annum, requiring about 16.1 million turbines to provide all the world's energy, weighing about 3.2 billion tons. Let's reflect on that. For just 29% of the fossil fuel weight used every year, in other words about 15 weeks worth, we could produce enough solar panels to power all of the world's energy needs for 25 years. Or for 21.5%, 11 weeks worth, we could build enough wind turbines to power the world. Yes, there is supporting infrastructure required, including transmission and storage, but it's hard to see how the total footprint of a completely renewable energy system could go beyond the combined weight of about 6 months of fossil fuel consumption. Companies are forced out of their comfort zones when moving from oil and gas to energy, but it also offers a mechanism to minimize transition risks. Some sizable oil and gas firms are getting ready to transform into energy businesses that offer customers a wide selection of fuels, power, and other energy services. This entails entering industries, most notably electricity, where there are already a wide range of specialized actors and where most low-carbon investment opportunities are far removed from conventional oil and gas projects in terms of scale and financial characteristics, with the possible exception of offshore wind. Given that it replaces oil as the primary component of consumer spending on energy in faster energy transitions, electricity presents prospects for long-term growth. The ability of the sector to strike a balance between diversification and anticipated returns and dividends will be closely watched by investors. It also opens the door to deeper and broader reductions in corporate emissions, reducing societal pressures along the way. The oil and gas industries are not necessary for the change of the energy sector to occur, but it would be more expensive and complex. Oil and gas businesses must explain how energy transitions will affect their operations and business models and how that might help quicken the speed of change. Company promises to cut emissions or intensities have already begun and are growing more widespread. No matter which course the world takes, climate impacts will worsen over the ensuing years, putting additional pressure on all facets of society to find answers. Within today's oil and gas paradigm, these alternatives are impossible. However, there is much more that the industry can do to combat the threat of climate change. What are your thoughts on this? Let us know in the comments section below. If you enjoyed today's video and found it interesting, make sure to leave us a thumbs up. And don't forget to subscribe to our channel and click on the bell icon to always be updated with the most exciting content as soon as it's uploaded. Thanks for watching. See you in another video.